Hi guys, Miss Hill here again, and we are finishing up our unit on linear functions. And today we're just going to get a little bit more practice with that linear programming. We're going to look at another real-world example here, how businesses use linear programming on a regular basis. So let's say that you are an assistant manager of Techdown Technologies, and the manager asked you to do a cost analysis to determine what stereo systems the store should order. Next month, you're going to order two types of stereo systems. We have the home theater audio system and then the shelf system. As assistant manager, you must determine how many of each brand is going to be used to, you need to purchase to maximize the profit. So if you expect to sell at least 5, but no more than 10 of the shelf system units. So I'm going to underline that in one color. So we're talking about the shelf system units there. We want to sell at least 5, but no more than 10 is what we expect. You also expect that your home theater system will not exceed 12. So we won't go over 12 with that. Now the number of shelf systems cannot exceed, it can't be bigger than the number of home theater audio systems. Now, we're also talking about the profit here. So, important to remember that each home theater system produces a $70 profit, and the shelf systems produce a $30 profit. So kind of reading over all that information again, we want to figure out what is the ultimate goal. What do we want to do? Well, we want to figure out how many of each type should be sold in order to maximize profit. So how many of each type should be sold to maximize the profit? Okay, so now we need to figure out our decision variables. What is it we're trying to decide? How many of each type? Well, what type? What is it that we're talking about here? So our X, that can be our home theater systems. And then I'm going to let Y be the shelf systems. It doesn't matter which you say is which, so long as you're consistent. You define those variables and keep your information consistent for each of them. You'll get the same answer. Alright, so now we want to write our objective functions. Remember, we are limited to things. So, using those limitations, writing our objective functions, we'll start with that, and then we'll get to the limitations or the constraints. Our objective function, remember, our goal was to maximize. We want to maximize the quantity. We're looking for maximum profit. So, what is profit going to be? Well, we said it was $70 for the home theater system, which was X. And then we earn a profit of $30 for each of the shelf systems. So our objective function, the profit will be equal to 70x plus 30y. Now we want to look at those limitations or constraints. So you could make a table if you wanted to, kind of like what we did yesterday. If you want to set up the table, by all means go ahead and set up the table. But I'm just going to go back through and look at what we underlined here. We want at least 5, but no more than 10 of those shelf systems. So remember, the shelf systems was our variable Y. So if Y is the shelf systems, then Y is going to be greater than or equal to 5, but then it also needs to be less than 10. Okay, so there's the limitations of our shelf system. Then we have our home theater system that we expect will not exceed 12. So if our home theater system was X, then x is going to be less than or equal to 12. Now here in the blue, remember we said that our shelf systems, the y cannot exceed the number of home theater systems. So that means that our y value will have to be less than or equal to x. Okay. Now here we're not going to use the common sense constraints because we've already limited our x and y values. Our y value should be greater than 5, or greater than or equal to 5, but less than or equal to 10. And our x is going to be less than or equal to 12. So now we want to use those constraints and put them all into, I put that up there twice. Now we want to graph our systems. So remember our constraints that we just said, I'm going to rewrite them here. We said that we had y is greater than or equal to 5, but y is less than or equal to 10. So I'm going to go ahead and graph those. So our y values greater than 5 along here. So it's going above, but less than or equal to 10. So that means I'm shading in between. So we're along there. And then we also said that we have x is greater than, or sorry, less than or equal to 12. So we have that vertical line and it's less than. So along here. And then we said that y has to be less than or equal to x. So that's just our parent function for linear functions. We have a y-intercept of 0, slope of 1, so we just have that horizontal line following through there. And that one was less than or equal to. Keep in mind, if you're ever not sure, you can use your test point. We won't use 0, 0 because that was one of them. But if we say our x value, we'll say 8, 2. If we test 8, 2, is it true to say that our y value of 2 is less than our x value of 8? Yes, it's true. So I am shading that part below. Okay. So we've graphed everything. Don't forget to label your axes here. We have our x, which is the home theater. Say the number of home theater systems. And then our y is the number of shelf systems. And our feasible region is where everything, I'll use the highlighter, that'll work better, where everything overlaps here. So that lovely trapezoid. So now that we have our feasible region graphed, we want to get those vertices, those corner points. So we can see that we have points at 5, 5, and then at 10, 10, at 12, 10, and at 12, 5. And we want to use that to find the maximum profit. So remember our profit equation. If we go back and look, it was 70x plus 30y gives us our profit. So if we plug in those values, 70 times 5 plus 30 times 5, and that's going to give us our profit, excuse me, of $500. Then at 1010, if we say 70 times 10 plus 30 times 10, that will give us a profit of $1,000. At 1210, we'll have a profit of $1,140. And at 12.5, we'll have a profit of $990. So, looking at what we found from each of those, we can kind of look ahead here and see there's our maximum profit at $1,140 at 1210. So let's make sure we understand everything that's going on here. If we're looking at just any point that's in a feasible region, that is going to say that this is a solution to the system. In other words, this is a possible combination that we could expect to sell. A point outside the region would not be a solution. So inside the region, this is a possible combination that could be sold. Where if it's a point that's not in that region, that's something that we would not expect to sell. So that would be a combo that would not be expected to sell. Alright, so we did find the maximum. I'll switch colors here. We said our max was $1,140, and then our minimum, if we look back at our table, the least amount was that $500. So if we're looking to maximize the profit, maximizing the profit, we're going to go back up to that maximum of $1,140. Since our ordered pair there was 1210, that means we should order 12 of the home theater systems and then 10 of the shelf systems. Alright, so now on your own, I want you to try the extension. Go back and see what would happen if we switched it so that you ordered no more than 20 home theater systems, even if it decreases the maximum profit. Alright, so the scenarios changed a little bit. You need to go back to the drawing board, revise your analysis, and figure out how many of each model should be ordered to maximize profit if you're going back and saying no more than 20 of the home theater systems. So try that one on your own, check your answers on Blackboard, then don't forget to do your homework. You can check those answers on Blackboard as well. If you have any questions, email me, send a remind message, ask in class, and I will see you then. Bye.